Hello students, here we are going to discuss how multiplication can be happened by signed numbers. Signed multiplication is nothing but the multiplication of two numbers that can be either positive or negative. For the negative representation we have to include one more bit called sign bit. Using Booth algorithm we can achieve the sign multiplication. This is the circuit for sign multiplication. Here, multiplicand can be stored in M register, product can be stored in A register, multiplier can be stored in Q register. One more extra bit can be added that can be named as Q0. Q0 is initially set as 0. A register also set as 0. By comparing these two values, we can decide either we are going to add or subtract or simply shift the values of these three registers. This is the algorithm we are going to use for signed multiplication. First you set the initial values. Count is nothing but number of bits we are going to use in the multiplication process. First we compare Q1 and Q0. That is nothing but last bit of multiplier as well as Q0 register. If these values are 1, 0, then you can do A equal to A minus M. If these two values becomes 0, 1, you can do A equal to A plus M. Or if these two values are either 0, 0 or 1, 1, you can simply go to the next step. This is ASR. ASR is nothing but arithmetic shift right. Arithmetic shift right of A, Q1 and Q0. The values present in these three registers are subjected to arithmetic shift right. Then you can reduce the count value into 1. Then you can check whether the count equal to 0 or not. If it is not, you can repeat this step again. After n number of times, you can complete the process. Then you can check the value present in product and multiplier. These both register value give the final multiplication result. Let's see one example. First you draw the table like this. The first column is count, that is number of bits present in the problem, and A register, Q register and Q0 register. In this example I am going to multiply -4 into -2. Before going to start the multiplication process, first I write the correct representation of these two negative numbers. The value given in the problems are 4 and 2. So first I write 4 and 2 here. That can be written in the 4-bit format. For the signed number, I want to include one more bit for representing the correct sign. So 0 means positive number, 1 means negative number. So these two numbers are positive numbers, so I include 0 here. So this bit is called sign bit. But in our problem, we are going to use -4 and -2. So +4 can be represented as -4 by means of 2's complement. So I am going to find the 2's complement for 4. So it is nothing but 11,100. So I can write it here. In the same way, 2's complement for 2 can be identified. That can be written here. So these four values can be used for upcoming calculations. So I can write these four values here. So before going to start the sign bit multiplication process, you should know the positive and negative values for both the multiplicand and multipliers. Now I am going to start this process. So as per the algorithm, first I set the initial values. The total number of bits for both multiplicand and multiplier are 5. So count becomes 5. A can be initialized as 0. Multiplier value can be stored in Q register. And one more register called Q0, that is always 0 at the beginning. So this is the initial value. Then compare these two digits. Here these two values are 0, 0. As per the flowchart, we can do the arithmetic shift right. So in the next step, we are going to do arithmetic shift right. Arithmetic shift right is nothing but first you write the first bit as it is, then you can do the normal right shift. So 0 can be written here, this 0 can be shifted here, then remaining bits are shifted one bit in the right position. So this is called arithmetic shift right. After that we can reduce the count value. So the count value 5 becomes 4. Then you can check whether the count equal to 0. Now the count value 4, you can repeat this operation again. Again you compare Q1 and Q0. Now Q1 and Q0 is 1, 0. 1, 0 means we have to do A equal to A minus M. So first you write the A value. A value is nothing but 0. M value is nothing but multiplicand. Here the multiplicand is 11,100. We have to do the subtraction operation. So instead of subtraction, we can write the 2's complement for this number. So 11,100 is the -4. The 2's complement number is 00100. That is +4. So instead of M, I can write the 2's complement of M, that is +4 here, and do the normal addition. I can get 00100. So this value can be updated here and we can write the same value for Q and Q naught in the previous result. So this is called A equal to A minus M. So after completing this, we can do the arithmetic shift right. So after apply arithmetic shift right, we can get this value. Then the next step is decrementing the count value. So the count value becomes 3. So this process repeated again. So we can compare these two values. So 1 means we can do arithmetic shift right. So again do the arithmetic shift right. Then reduce the value. Again you compare these two values. So these two values again 1. So you can do arithmetic shift right again. Then reduce the count value. Then compare Q1 and Q0 again 1. Then you can do the arithmetic shift right. Then reduce the count. Now the count value is 0, so you can stop the process. Then finally, A and Q, both the value give the final product result. So minus 4 into minus 2, we can get plus 8. This 0 indicates the positive number, so this entire result gives the plus 8 value. Suppose if your problem is minus 4 into plus 2, so this is the multiplicand and this number is the multiplier. So this multiplier can be written here. Then you can do these steps as per the flowchart. Finally, you can get this result. So this entire number is treated as the final product. This one indicates the negative number. So negative numbers means you want to find the exact value. You can find the 2's complement for this 10-digit number. If you are converting this number into 2's complement, you can get 8. So this number is nothing but minus 8. So for this signed multiplication, you should remember this flowchart as well as how to write the correct representation of positive and negative numbers. I hope you understand the signed multiplication process by Booth's algorithm.